What are these guys doing, dude?
I don't know, man.
We're gonna eat them alive in a game of basketball.
For sure, for sure.
Hey! We got net.
No, dude, you already stole my series. Now you're trying to steal my court.
You guys are going down. I'm beating you guys to that.
Oh.
There's no shot, bro.
Me and my buddy
Stole his
boys.
series, dude. What are you trying to do, bro?
Brad Fremont!
Hey, you guys should play a match to figure out who's the best mathematician. First, you guys got to figure out where the ball is.
That sounds good with me.
Yeah, I'm also down.
No one asked you to do this.
I'll go find the ball.
Seems kind of flat. You might need to pump some air into this.
The basketball is being inflated at a rate of 4 cubic inches per second. How fast is the radius of the basketball changing at the instant the radius is 4.5 inches? We know that the volume of the basketball is modeled by the equation 4/3 pi r cubed. Now, differentiating this equation in relation to time, you get dv dt equals 4 pi r squared dr dt. Now, rearranging the equation to solve for dr dt, you would get 1 over 4 pi r squared times dv dt. Now, when you plug in the values you got from the initial equation, you find out that you have 1 over 4 pi times 4.5 squared, because that's the radius the basketball is at that instant, times 4, which is the rate at which the volume is changing. This gives you dr dt equals 1 over 20.25 pi, which equals 0.0157 inches per second. Alright, so using that number, the ball should be perfect right now.
I think we're ready.
You think a perfect ball can help you win the game?
Your shooting percentage is so low that even imaginary numbers would help.
You're just like a Taylor polynomial. All approximation, no real game.
Okay.
Shut up, nerds. Let's get this game started. You realize you can play now. What is this guy doing?
The basketball player's movement across the court is represented by the function x of t is 3 sine of t squared plus 3. The player's movement towards the hoop in feet is represented by the function y of t equals 5t. Find the total distance traveled by the basketball player from the moment the play starts to the moment his teammate shoots the shot at 2.5 seconds. So to find the total distance, we need to use the arc length formula, which is the integral from a to b, the square root of dx dt squared plus dy dt squared dt. Dx dt is 6t cosine of t squared, and dy dt is equal to 5. So when we plug these equations into the arc length formula, we get 18.408 feet that the player moved from 0 to 2.5 seconds.
It's our game plan. Boom! Ah!
You're like a divergent series. No matter how much time we give you, you're never adding up to anything. Hey, look, a calculator.
Where?
There's discontinuity in this game. Everything's smooth until you show up.
Fundamentals, baby. Fundamentals. Fundamentals. They call me LeBron.
You're not very good at blocking, EULER. It's not my name. I can't see.
I'm sending you more directions than the graph of a rose curve. Oh.
It's me and you thief.
While you were so busy worried about me stealing your formulas, I just stole the ball.
Shoot that, Euler. Shoot that.
You have one foul shot.
You get the foul in, Taylor.
Hey, take your time.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Keep shooting. I need more examples of an exponential decay.
With the clock winding down, green has one more chance to win.
Wait!
What are you doing, bro?
The motion of Lagrange's shot is modeled by this equation. Y equals negative 0.6 times x minus 2.75 squared plus 12. Find the maximum height of the basketball and the time it will maybe enter the 10-foot tall hoop. To find the maximum height, we're going to take the derivative of this function, which ends up being negative 1.2 times x minus 2.75. Then we set that equal to 0, and we find that at 2.75 seconds, the ball will be at its maximum height. And we can justify this by taking the second derivative of the function, which is just negative 1.2, and because that is less than 0, we can say it's concave down, meaning that there is a max at 2.75. So then to find the maximum height, we just plug 2.75 back into our equation. Do some algebra by subtracting by 12, dividing by negative 0.6, and taking the square root. So now we're left with plus or minus 1.826. Then we're gonna add 2.75 to both the positive and negative 1.826. So we are left with 4.576 seconds and 0.924 seconds. Now we want the second one because with the shot, it's going down at the 4.576.
Can they find a way to score the winning point before time runs out?
Final score, 0-0. Oh my god, that's so hot.
Let's do football next time.